Iterables. Iterables are a sequence of data types put together as one derived data type. It is a collection of data types stored inside a quote, a single or double quotes, inside a bracket, a square bracket, or a curly brace. Iterables can return its members one after the other. Examples of iterables are lists, tuples, string, sets, and dictionaries. Below a list of iterables, the first three are lists. We have a list of numbers, a list of different data types. To identify a list is enclosed in a bracket, in a square bracket. A tuple is enclosed in a normal bracket. A string is enclosed in a quote, either a double quote or a single quote. A set is in a curly brace, and a dictionary is also in a curly brace. Let's talk about function classes and methods that is used in all those iterables. The first and simplest one, which is not specific to iterables, is the print function. The print function will print out the value in an iterable. I want to print out set 2. I'm just going to type in set 2. I can also print out a list, lst2. So you see, it prints it out. Another class not specific to iterables but is used to see the type of iterable you have is the type class. I can do type. Let's do str1, which is a string. To see the result of this, you're going to type print to print out the result of type. Okay, so this prints out the type of variable you have. In this instance, we have a string. If we do data1, it's going to show us that we have a dictionary. If we do set 2, it's going to show us we have a set. If we do this variable tup, which is a tuple, will give us a tuple, and lst will give us a list. Let's talk about classes, functions, and methods that are specific to iterable. And the first we're going to talk about is the list, dict, set, and the string classes. All these are how you define an iterable. You can use it to convert any iterable to another one, or you can use it to declare a new iterable. If I want to declare a new iterable, lst4, I can just say it is a list. I'm just going to call it directly, and it declares lst4 as a list. If you look right here, you're going to see lst4 as an empty list. Of course, if you want to print it out to make it easy, let me print out lst4. Print lst4. This is a list that doesn't have anything. You can do that if you want to change to a dictionary. Let me change this to var and this to var. So this var is a list. To a dictionary, you do dict, which is dictionary. So this var now is a dictionary. The same thing if you want to do a set. It's going to show you that you have a set. If you want a string, it's going to show you a string. It's actually an empty string. That's why you're not seeing anything in there. You can also declare the iterables using their parentheses. For instance, if I want to declare a list, instead of doing lists, I can just use the two curly braces to define an empty list. And same thing, if I want to do a string, I can just put two double quotes or two single quotes to declare an empty string. I can do the same thing for a tuple. This will declare a tuple, and also for a set or a dictionary. The len function. The len function returns the number of items in the iterable. If you have an iterable and you want to know the number of items in it, you can use the len function. For instance, we have this tuple and we want to know the number of items in the tuple. We can just do len turp, which is the length of the tuple. To see it, we can put it in a print, and then it's going to tell you, it's saying that there are 10 items in turp. Let's look at the number of items that is in LST3. I'm going to pick these and put it here. And you can see there are 3 items in LST2 here. In LST2. Yeah. So item 1, 2, and 3. Main function. This returns the minimum number in the iterable. If you take an iterable of numbers, you can use the main function to return the minimum number in the iterable. In this instance, let's look at this list, and we have if we print out the list, LST is going to print out all the items in the list. But if you put LST in minimum, if you call the minimum functions on LST, it's going to give you the minimum number in LST. Like min, we also have the max function. The max function returns the maximum number in the iterable. In this instance, I can do max, and it's going to give me the highest number in the iterable is 56. The minimum number in the iterable is 4. Let me give it a description. Minimum and maximum. So you can see minimum number here is 4 and the maximum number is 54. Let me print out the whole list. LST. This is the whole list. This is the smallest number there, and this is the highest number in the list. Items in an iterable are stored at different locations in the iterable, and these are indexed. The first one is on index 0. They are numbered from 0, 1, 2, 3, 4, 5. So item number 5 will be on index 4. Item number 10 will be on index 9 because it actually starts numbering from 0. So to access an item in an iterable, say using lists, you will have to use the index, and this is done using the square bracket. I'm going to store LST, which is a list, here inside a variable called results, and I'm going to print out results. So results will be the content of LST. Right now, result is showing all this. Now, if I want to see the first item, which is 12 in LST, that first item is on index 0. So what I'll do is that in front of LST, I will put a square bracket and I'll put 0. Now with that, it gives me the value 12. If I want to see, say 1, 2, 3, 4, 5, 6, this is item 6, but item 6 will be on index 5. Item 6 is 12. If I say 5, you see it's showing 12. This can also be for tuple, TUP, this tuple. I'm calling this tuple, and I'm looking at the second index, which is 56. And it can also be for string. You can pick, let's take this string, str2. str2. The third item in str2 is B, but it is the second index. In the case of a dictionary, Let's try it. If you say data 1, it's going to give you an error, key error. It doesn't understand what is 2. In the case of a dictionary, you're going to specify the key. And in this instance, if I want to print out Emmanuel, I'm going to put name right in the square bracket and it will print Emmanuel. So the key, I put a key and the key will give me the value. I can say gender and it gives me the value male. You can, however, not implement an index for a set. Let's try doing this for sets 1. Set 1 is this, and then we'll do a square bracket and 0. So it say set object is not subscribable. This is because set is an unordered iterable. The other ones are ordered iterable. That's why you can pick the index. But if it is a set, you won't be able to pick the index. An iterable can take in other iterable. In this instance, you can see that in list 3 is a list, but it has in it 3 tuples. If I do, for instance, the length of LST3, it's going to show me there are 3 items there. 1, 2, 3. And if I do LST3, the first item, is going to return a tuple. The answer will be a tuple because this is a tuple. So iterables can contain other iterables. Look at this instance. In data 2 names contains a list. Slice syntax. The slice returns a substring or part of an iterable. Let me just write out a variable that takes in a string str2 and print out this result. So basically, I'm printing out subscribe to my channel. If you haven't subscribed to my channel, please, you can do that right now. When you put these, you print out this, you can use the slice, which is a square bracket, and it has a column in between, and the column in between has the start where you want the subsection you want to cut out, the part in your string that you want to cut out. Now, right now, subscribe to my channel is just one string. You can decide to cut out, or you can decide to bring out just a part of this using the start value, the start index, and the end index. So in this instance, if I want to write scribe, the start index will be 0, 1, 2, 3. So this will start from 3, and then the end index will be 0, 1, 2, 3, 4, 5, 6, 7, 8. This is what I want to print out, scribe. So it's going to do, this is 8, and I'm going to put in, I'm not going to put in 8, I'm going to put in 9. That is, I'm going to add 1 to it so that it will print out only scribe. The syntax is start index, end index plus 1. So if I want to print out UBS, what I'll do is I will say start index UBS. The start index is 1, column S is the end index, that is 0, 1, 2, 3. That is 3. 3 plus 1 is 4. So it's going to print out UBS. You can use this for any other iterable you have. You can, for instance, do for a list. In this list, it's printed out starting with the first index, and it's printed out to the third index. You can also put in just one item. Instead of having two, you can just say print from one. It's going to start the printing from this. So if I say print from 3, it's going to start the printing from the third index. That is 0, 1, 2, 3 to the end. It's going to print from the third index to the end of the iterable. If you want to print from the last index, saying I want to print from the last index to the first, say I want to print from index 4, it's going to start from this to the very first item. So it's going to start from this. Like I said, this is 0, 1, 2, 3. It's not going to add the fourth one. It's just going to start from the third index, and it's going to print it to the first because you didn't specify the first index. And of course, if you put the 4 here, it's going to start from the fourth and it will print to the last because you didn't specify the end index. And if you want to put the end index, of course, you can also add the end index. It's going to start from 4, index 4, and it will print to index 8. You can also do a reverse printing where it prints from the last index, and that you can do using the -1 index. This is printing only the last item. I can put the column here, that is jump the first item and end at the last index. So it's going to actually print out everything. If I want to start reading from behind, I can say start from 1, 2, 3. That is -3 to -1. When you're using a negative index, it starts from the last, from the reverse, and the first item in the reverse is -1. If you say -3 column -1, it's going to count to the third item from behind, which is 1, 2, 3, which is 4, and then it's going to also go to -1. This is -1, but it's going to jump, it's going to skip the last item, and it's going to print only 4 and 7. If you want to print all the item from the third index from behind, you can just remove the -1. It's going to print 4, 7, and 34. There is a last parameter in using a slice. The last parameter is the step parameter. In the step parameter, you can decide the step it takes when printing. The default value for step is 1, and that means when it's printing, it's going to start from one item and move to the other item, and then to the other item. But if you change the step, let's say in this instance, you change the step from 0 to 9, you change the step to 2, it's going to start from 0. It's going to jump, because you say 2 steps, it's going to go 1, 2, it will print 56, it will go 1, 2, it will print 4, 1, 2, it will print 41, 1, 2, it will print 7. This is because we have in here step 2. If you do step 3, it's going to print out 12, then it's go 1, 2, 3, it will print out 23, it will do 1, 2, 3, it will print out 41. You can see that result here. You can use the step parameter to reverse the order of your iterable. If you want to do that, you just do column, skip the start, skip the end, and do -1 in the step. This will reverse the order. This is the order 12, 34, but you can see here the order has been reversed because of the -1. Let's change this to str2. You see, it's going to reverse the subscribe. This is an easy way to reverse the order of your iterable. The in keyword. You can use the in keyword to return a boolean if a value is in your iterable. The in keyword basically checks if a value or if an item exists in an iterable. Let's take an instance. Let's look at LST. I can say, is there the number 23 in LST? So I'll say 23 in LST. If there is 23 in LST, it's going to return the answer to results. And that will be either true or false. So here it says true because there is 23 in LST. But do we have 21 in LST? No, there is no 21 in LST. So you can see the result is false. And if you want to check if there is no occurrence of a value, you can use the not operator. So I can come here and say not in. That is 21. Is 21 not in LST? That's true because 21 is not in LST. So you can use these not only for integers, you can also check for text. Let's say in string 2, I can say is channel in str2. You look at it here, it returns true because channel is in str2. Note if I change this to small letter, it's going to say false because it's case sensitive. If I say subscribe in string 2, that is true. And I can say subscribe not in string 2, it's going to say false. You should also be careful of the type because if it's not the same type, it's going to give you false. Let's look at this. It's 12 in LST. Yeah, that's true. 12 is in LST, but is this 12 in LST is showing false because LST has an integer 12, but here is a string 12. So it is not the same thing. So it's saying that string 12 is not in LST. If I come here now and put in a string 12, the answer will change to true. The sum function. This returns the sum of all the values in the iterable. This is used for values that are integers. So let's look at LST. I'm going to store the results in results, and I'm going to print it out. So LST, this is everything in LST. If you want to check the sum, just do sum of LST. This gives me the result 227. That is, if you add all the content of LST, it's going to give you that result. We can also add the content of a tuple, and it's going to give you the same thing because they are the same numbers. Let me change the number. You'll see a change in the tuple there. Sorted function. Use the sorted function to sort the element in non-iterable. So let me do that. I'm going to start the results here. I'm going to say sorted and print out the result. So here I'm going to sort LST, and as you can see, LST has been sorted, and I can sort any iterable. I can sort top, it's sorted. I can also sort a set 2. It's going to sort the items in the set, and also I can sort my data, that is my dictionary, which will sort only the keys in the dictionary. You can also sort a string too. If you want to sort the string, it's going to break down everything into a list and sort it out. The any function. Any function returns true if any item or expression in an iterable is true. Let's take a look at this list with 3 items. To use any function in its simplest form, we're going to test if the items in this list are all greater than 0. That is, they are not 0. Any item that is 0 is false. So if you say, let's say results equals to any list 4. So let's print out the result. It's going to say true. That is because the items in list 4 is all not 0. And it doesn't have to be all. One can be 0. As long as you're using any, it's going to give you true. That is, if any of them is true, then the answer will be true. If I put in another one, it's going to be true. It is when every one of them is a 0 that it turns to false. Any is mostly used when you're dealing with multiple expressions you want to test. With any, you can test a series of functions, expressions, and whatever value they return. Any will test them all together to decide if it is true or false. So let's look at this in this instance. Run maybe a function, maybe an expression, it returns true, and sit returns true. So if I want to test all this together, run and sit, I'm just going to put it in my iterable and put the two, run and sit. Because run returns true and sit returns true, the answer will be true. Any will return true. If I change this to false, any will still return true, because if any of this expression is true, any will return true. But if I change sit to false, it will return false. So any just returns true if any of the expression is true. Let's do another example. I can say 10 is greater than 3, which is a true expression. I can say another 10 is greater than 9, which is a true expression. And say 20 is greater than 10, which is also a true expression. So all this is going to return true. If I change 20 is less than 10, this is not true. So it's still going to return true. If I change the other ones, 10 is less than 9 is not true. It's still going to return true because 10 is greater than 3 is true. Now, if I change this to less than 10 is less than, then all these expressions are false and it returns false. All functions returns true if all of the items or expression in an iterable is true. All function is like the opposite of the any function. In an all function, if I say result equals LST, I want to start result in LST and then print out results. If I say all LST, is going to return a true or false. Now, as long as the expression or the item in the list is true, or in other words, in a normal list, if there is a number in and the number is not 0, then it's going to return true. Number 0 signifies a false expression. So if I put 0 here right now, it's going to return false. All function says all of the list must be true, or all of the expression must be true. So if you take out 0, it means all these are numbers greater than 0, so it's going to be true. Let's take another example. Let's use all function for, let's say, list 5, LST 5. And I'm going to put in 3 expression. The first expression is 10 is greater than 3. That is true. 10 is greater than 8. That is true. And 20 is greater than 10. That is also true. So if I print out LST 5, it's going to return true. But if I say 20 is less than 10, it's going to return false, because every expression in it must be true. Let's look at another example. LST 6 So I'm going to use a list and say 23 in LST. This is LST. There is number 23 in LST, which is true. And I'm going to say subscribe in STR2. Is there subscribe in STR2? This value evaluates to true. And I'm also going to say 4 in LST. In LST, is there 4 in LST? Yes, there is 4 in LST. Now let's print out 6. You can see right now when we print out all, we say all. Is all the expressions here true? Are they all true? Yeah, they are all true. So if I say 47 in LST, there is no 47 in LST. So this is true, and this is false. So, and then that will return a false statement. So in the case of all function, your expressions or your items must all return true. And it is used basically to test several expressions that returns a Boolean to see if they are true or false. Multiple assignments, unpacking iterables. If you want to put the contents or items in an iterable into another variable, the normal way to do that is say X is, let's do that for ls2. I'm going to put the first item in X, and in Y, I'm going to put the second item. There are 3 items in there, and in Z, I'm going to put the last item. So if I print out X, Y, and Z, it's going to print out the items Emmanuel, 47, and male that is in the list. But there is a way you can unpack this or assign it using the usual multiple assignment done for every other variable. So let me comment out this. So a way to do it is to say X, Y, Z equals to LST2. With this, it unpacks. It knows that the first item will be put in X, the second item will be put in Y, and the third item will be put in Z. As you can see right here, it has unpacked it. When you unpack, you have to have the same number of variables matching the same number of items. Let's say in an instance, I put another variable called A. Now, it's going to give you an error saying not enough value because there are 3 values in there and you have 4 variables. In this instance, you have to put in an iterable that has that same number. For instance, we can use the set2. You see, it's not bringing out an error, so we can actually print out all the data in that. So X goes for an item in the set, and Y, Z, and A goes for different items in the set. Let's try to unpack a dictionary. I'm going to use data1. Data1 has 3 items in the dictionary. So I'm going to use unpack just 3 items, and then I'll use data1. Now, if you are unpacking items using a dictionary, it's only going to give you the keys. You can see right here you have name, age, and gender. But if you want to unpack it, X to contain the name and the key and the value, you would have to use the items method. So with the item method, it's going to unpack the key and value into a tuple. You can see it right here. X contains this, Y contains this, and Z contains this. So you have the key and value in a tuple. So I can print out X so you see what I'm saying. So you can see X has name, which is Emmanuel. If I print Y, it has age, which is 47, and Z will have gender, which is male. So unpacking a dictionary will require you to put in the items method for dictionaries. For loop. The for loop loops through the items in an iterable. So to loop through an item in an iterable, I can do for. I'm going to loop through the items in ls2. So I say for data in ls2. So it should give me, okay, I'll say for item in ls2, and then I'll print out item. So what this does is that it puts each item in this item variable and it prints it out. And then it loops again, put the next item in the item variable and print it out. And then also it does that for all of them. And so you can see here, it's listing out Emmanuel, 47, and male. This you can do also for a tuple. It's going to list out all the contents of the tuple. If you want to use a dictionary, let's say data 1 is going to print out only the keys, name, age, and gender. If you want to print out the values, you can use the dictionary method of values, and then it prints out each of the value. If you want to print out the value and name, you can use the items, the values, and the key will be printed out in a tuple. If you're printing out a string, it's going to print out each item in the string. Let's print out str2. You'll see it prints out each item as you subscribe to my channel. It prints it out one after the other. You can use a for loop or a while loop to implement this functionality, but the one that is most used and that is shorter and more understandable is the for loop enumerate. Enumerate can be used to add index number to each iterable when you are looping through it. For instance, if I have if I loop through lst2 and I print out the item, it's going to print out Emmanuel, 47, and male as it is in lst2. But if I want to see the index of each number, I'm going to use enumerate and put the list in enumerate. And as you can see, it prints out tuple of each item. That is, the first item is 12 and it is on index 0. Second item is 34, is on index 1. And if I want to print out the index differently, I'm going to say num. Num means the index, those numbers. And then, so I can print it out this way. I can say num, comma, item. So num is the 0 to 9, and then the item, each item is the items that is in your list. If I print out only item, it's going to show you 0 to 9. Those are the indexes. But I can add, okay, let me make it a little bit more intuitive using the string F format. So I'm going to say, so right in here, I'm going to print out num, and at the end here, I'll print out item. It's going to show it this way. Or I can just do this, take out the commas. So it prints out this way, printing out the nums and the items. By default, enumerate start the index from 0, but you can change that by putting a second parameter, which is the number where you want the number to start from. So I'm going to say start counting from 1. And as you can see, the count is now different. It's counting from 1. Of course, you can change which number you want it to count from. I can say count from 11, and it's going to do that. It's going to count from 11. It's going to enumerate, put a number by each item in the list. Comprehension expression. The comprehension expression is a better way or a shorter way to loop through an iterable using just one line of code. And you can also put in an if statement to just in that one line of code. Let's look at a conventional loop statement. For instance, I'll say for item in list 2, and I print out item. It's going to print out all the items one after the other. It's going to loop through it and print it out. But you can achieve the same code doing this. You put a square bracket, and then you first print out the item you want, and then next you do the for loop for item in lst2. So let me comment this out, and you'll see the same results. So in this instance, I say print out each item for the item that you find in ls2. So it's going to print out, you see this command is the first line that we have in the conventional loop, and then this command is the second line we have in the expression in the code we wrote in the conventional loop. But you can get all that doing this. Say I want to print the output of my list into another list. So let me create another list. I'm just going to call it lst5, and I'm going to make it an empty list. And I'm going to say lst5 dot append. Append is to add an item into an existing list. So it's going to add this item into this list. It's going to do it the first time. It will take the first variable in lst2, that is Emmanuel. It's going to add it to lst5. It will do the second one, take 47, add it to lst5. So basically, it's just going to create another variable lst5 that contains everything that is in lst2. So let's print that out, lst5, and you will see this print out a list of what is in lst2. They have the same content now. You can achieve this just using the list, the comprehension expression. This is a list comprehension expression by saying lst5 equals, and then you can print out lst5. And of course, you're gonna remove the print command. Basically, what it's doing is that it loops through lst2, take each item and put it in items, and then put all that value in lst5. So I'm printing out lst5 right here. Let me print out the value in lst. So it prints out all this value in lst. I can change the output to a set. If I want to change the output to a set, at this point, the output is in a list. If I want to change the output to a set, I'm going to change this to curly braces. But if you notice that the output is a bit shorter than what it is here, a set does not print out duplicate values. So in this instance, where you have 4 appearing twice, you only have 1 occurrence of that in set. So set does not allow you to have duplicate value in it. That's what differentiates a set. And if you would notice, you will see that in this set 1, we have duplicate values. We have 4 appearing twice. This is not a correct implementation of set. Now, you can be confused because if you print out this set, it's not going to print out all this. It's actually going to remove all the duplicate values. It's not going to print out those duplicate values, even though I have it declared this way. But when you print it out, or rather the content of the set 1 will be this, because set doesn't take in duplicate values. You can also put a condition in your comprehension. Let me put it back to the list comprehension instead of a set comprehension. You can put in if condition, and that you put in after here. Say, I want it to print out only items that are less than 30. So with items less than 30, it's going to print out only items in this list, in list LST, that is less than 30. You can, of course, do several other calculation. I can say only print out items that are divisible by 2. That is, when you divide it by 2, it gives you 0. So it's only going to print out items that are divisible by 2. If you want to print out items that are not divisible by 2, you put not equals to 0, and it's going to print that out. So you can see in just one line, we have the full expression, we have a for loop, and then we have an if statement. And it could be for a set. It could be for a set, and it could be also for lists. Let's take out this if so we can have more output coming out. If you want to do for a dictionary, all you need to do is you specify, okay, the example I want to do now is a dictionary that will make the key a number, and then the value will be a multiply by 2 of that number, whichever number that is in LS2. So let's give it a try. Dictionary is taking curly bracket. I'm going to say item, then column item multiply by 2. So item multiply by 2, you know, this will be the key and this will be the value. Same way it is done in every dictionary. So you can see it right here. It's printing out 12, column 24. This is a dictionary that we created using the list comprehension. Let's turn LST into a dictionary. We can do this and say for item in LS3, LS3 is a list of tuples. And to get out the items in a tuple, there are 2 items in this tuple. I can say num, comma, item, or name, comma, age in LS3. So it's going to store each name in name and store age in age. So, and then I'm going to get that from here. So I'll say name, column, age. That will be stored as a dictionary. So when you print it out, you will see in here it says James is 34, Emmanuel is 23, Deji is 27. So I've been able to successfully convert a list of tuples into a dictionary.